Hello everyone and welcome to today's webinar focused on cooking appliances. While we wait for all the other assistants to join, I just want to introduce myself. I'm Jackie Garcia and I'm part of the Efficiency for Access Design Challenge team and the facilitator of this webinar today. As a reminder, these webinars are designed for the participants of the Efficiency for Access Design Challenge, which is an initiative led by Efficiency for Access with support from Engineers Without Borders UK. This webinar is being recorded and the cameras and microphones are disabled except for those of the main speakers, but you all can use the chat box to make any comments or questions for our speakers at any time, and we will discuss at the end of the presentation. I would like to introduce our speakers today. So we can go to the next slide. John Leary is a researcher at Modern Energy Cooking Services, most commonly known as MEX, working on empower everyday cooks, develops and trials innovative solutions. Second speaker is Leonard Shurg. He is the head of production innovation at Burn. He dedicated his career to sustainable future and green energy. Leonard worked previously on product development, validation, and product process. His project portfolio includes cookstoves, solar heat, and electricity. Then we will have Mr. Biraj Gautam, who is the Chief Executive Officer of People, Energy and Environment Development Association, PEDA for shorten, and he brings more than 12 years of professional experience as a manager, leader, and an environmental professional. He has an extensive work experience as an environmental energy practitioner on various research and development projects related to hydropower development, rural electrification, solar wind, hybrid system, electric cooking, and biofuels related projects. He's mainly involved in the planning, implementation, monitoring of community-related projects, and also leads several technology research projects for Nepal. Mr. Gautam holds a Master's of Science in Environment Science from Tribhuvan University. Unfortunately, Mr. Biraj is not able to join us today because it's a big festivity in Nepal, but he didn't want to miss the opportunity to be here today, so he sent us a video to share with you today. And now, without further ado, I want to give the floor to John for the first presentation. So John, whenever you're ready.
Thanks, Jackie. Shall I turn on my video? Can you see me okay now?
Yes, perfect. Thank you.
Great. Okay. Well, thank you so much for the opportunity to share some insights from our work with you today. I work for Modern Energy Cooking Services, a UK government-funded research program exploring the opportunities for people who currently cook with biomass to transition directly to cooking with modern energy. So my name's Dr. John Leary, and I'd like to share some insights with you today around the emerging opportunities for cooking with electricity. Next slide, please. So I'd like to try and answer, next slide again, please. I'd like to try and answer three key questions today. I would like to try and show you what new opportunities are on the horizon for cooking with electricity or e-cooking, which electric cooking appliances are most efficient and why, and how can we make electric cooking accessible, desirable, and affordable. Next slide, please. So in the energy access sector, then the traditional narrative has been that in order to achieve Sustainable Development Goal 7, which is to enable access to reliable, affordable, and modern energy for all, we have to tackle these two goals, two parts of this goal separately. We have to enable access to electricity, and we have to enable access to clean cooking. Whilst in recent years there's been rapid progress in access to electricity, meaning that there's now less than 1 billion people in the world today who are without access, there are still more than 3 or just under 3 billion who are without access to clean cooking. Progress has been very slow, and in some contexts, in many sub-Saharan African nations, for example, population growth has outstripped the rate of gain in access to clean cooking, meaning that progress has been negative. And there's traditionally been a focus on improving the efficiency of biomass cooking, making more efficient stoves, using more sustainably sourced fuel. However, electric cooking, a solution which has the potential to leverage this progress in electricity access to achieve clean cooking goals, has historically been ignored by the clean cooking industry because of many of the reasons that we see on the right here. Many people did not have access. However, as I mentioned, this is now changing. Wiring in many contexts is not strong enough to support directly using electric cook stoves. Blackouts and brownouts or voltage dips often mean that the power of sufficient quality is not available when it comes to the time for preparing a meal. So these many challenges have meant that cooking with electricity has largely been ignored. However, next slide, please. There are new opportunities on the horizon. What we see now in particular is that the falling cost of solar PV and of battery storage and the rising cost of biomass fuels in many contexts where deforestation is a particular concern, coupled with the emergence of new energy efficient cooking appliances such as induction stoves, infrared stoves, rice cookers, and electric pressure cookers, has opened the door to a set of new solutions which have been available previously but have not been cost effective enough to use in a development context. So what we see on the bottom left here is a simplified typology of electric cooking system architectures. So what I mean by this is the different configurations that you can use in order to power an electric cooking appliance. On the top left, you see a simple AC electric cooking device plugged into a grid. And this is what we're most accustomed to, what many of you will have in your own homes. Buy an off-the-shelf appliance, plug it in, it works as long as power is available. However, on the bottom left, we see a configuration that is more suited to areas where the grid is weaker, where the power may not be available when you want to cook. So by using a household battery and a DC cooking appliance, then you can buffer that instability in the power supply and cook when you want to. On the right-hand side, we see a set of off-grid solutions. By using a solar panel coupled with a DC cooking appliance, with or without a battery, this can enable people without access to any form of grid electricity to cook. We see in the photo on the right-hand side here, a colleague of ours, Maureen in Kenya, trialing a DC electric pressure cooker, which is powered from the batteries on the left-hand side of the picture. Next slide, please. So we've seen a revolution over the last decade in terms of access to electricity for lighting. And a lot of this has been enabled by the LED. So the LED offers an appliance that can deliver the same energy service, lighting, with 90% less energy than the appliance it was replacing, the incandescent light bulb. This means that the supporting power system can be 90% smaller and 90% cheaper. So a lot of our research is focused on finding what could be the LED of battery-supported electric cooking. Are there electric cooking appliances that can offer similarly drastic reductions in system sizing and therefore cost, and therefore enable access to electric cooking services to a much wider range of people? Next slide, please. So we created a typology of electric cooking appliances to categorize them into three broad categories. So inefficient conventional appliances, as you see here, such as the electric oven with 4 hot plates on top, or the standalone plug-in hot plate. Whilst these are great at heating up the room that you're cooking in and the cook themselves, they're not so great at directing that heat into the food. So they're often very high power rating, which means that it's very difficult to supply these devices with an off-grid system, both in terms of the power consumption and their energy consumption. So the size of the battery that would be required to support these appliances is very large and therefore very expensive. Next slide, please. So in the next category, We have slightly more efficient appliances, such as the induction stove or the infrared stove, which generally focus on increasing the efficiency of getting the heat into the cooking pot itself. The induction stove, such as the one in the picture here, it's very efficient at using a different form of heat transfer, so magnetism, in order to transfer the heat directly into the pot itself, but it's just as inefficient once the heat is in there. The heat can leave, next slide please, the heat can leave through a variety of mechanisms such as convection, radiation, and steam evaporating from the top of the pan. So what we've optimized here is the bottom element here, the red element, the efficiency of heat going into the pan, but done nothing about the other forms of heat transfer that lead to inefficiencies in the cooking process. Next slide, please. So what we've learned is that actually there are huge efficiency gains simply by thinking inside the box. So by insulating the cooking pot and insulating the heater inside the pot as well, which is something that's really only possible with electricity, because if you think about it with an open flame, then either you're going to set your box on fire or your flame's simply going to go out. This is a real leap forward in terms of efficiency. We can not only improve the efficiency with which heat goes into the pan, but also we can keep that heat in once it's in there by minimizing the losses through evaporation, convection, and radiation. Next slide, please. So we have a set of even more efficient modern appliances, which are insulated. These include the rice cooker, the insulated electric frying pan, and the electric pressure cooker. The latter appliance, my colleague Leonard, I'm sure is going to touch on in his presentation afterwards, but this also includes another element of energy saving, which is pressurization. So by raising the temperature of the water inside above boiling point, we can cook faster, and the faster you cook, the less energy you use. This is particularly important for those foods where you're boiling for a long time. So the typical power requirement of these devices is also lower. So that means that they're much easier to power from an off-grid system or from a grid-connected battery-supported system. Next slide, please. So in order to enable cooking with electricity, in particular for lower income households, there's a need to find cost-effective solutions. What we did in our report, which will be launched very, very soon, called The Cost of Cooking with Electricity, we modeled a bunch of a selection of different appliance configurations using cooking diary data that households recorded for us whilst they were cooking with different types of appliances. What we found was that on the left-hand side, you see those very inefficient appliances, the oven and hot plates, and the plug-in hot plates, which have a very high cost of cooking in terms of how much you'd have to pay each month to cook your food with these foods. On the right-hand side, the gray bar is an appliance stack of inefficient and efficient appliances together. However, the lowest cost solutions are where you're really using the most efficient appliances, especially to do what they're most efficient at. Those two orange bars on the right-hand side are electric pressure cookers, either cooking half of your food or just boiling the heavy foods. So what we see is that if you can identify culturally appropriate energy efficient appliances, which I'll come back to later in terms of how you can do that, you can really reduce the costs of the cooking solution by optimizing the energy demand. But at the same time, these solutions can be highly desirable to consumers because they can make cooking much easier. However, there is a catch in that the most efficient solutions generally cannot cook all types of foods. So it's important to make sure that you're selecting appliances which match well with local cooking practices, and that you expect that people will stack their fuels or appliances. So stacking means simply using more than one cooking solution at a time. For example, using a hot plate and an electric pressure cooker, or using an electric pressure cooker and LPG. Next slide, please. So what we see on this slide is the same graph, but I've just added in the cost of the battery to support the cooking appliance in a weak grid scenario. So what you see here is the difference in cost is magnified because every watt hour storage has to be has an additional cost to it. You have to buy a larger battery to support the larger appliance. So now you can see the oven and hot plates is even off the top of the graph. It's so high it's not even worth considering. However, the electric pressure cooker as a standalone appliance is still relatively affordable in the region of $5 to $10 US per month for cooking half your food, or $3 to $4 US per month for boiling heavy foods only. So this has been enabled by the development of new service delivery business models because the upfront costs are typically high. This could be in the form of pay-as-you-go, so same as has enabled access to solar lighting across much of the global south, or utility business model, which is what energy service companies such as electricity, grid electricity companies, or water supply companies, how they typically bill you per unit of energy or water in that sense that you consume. So they break down those high upfront costs into manageable repayments. So battery supported cooking, making sure that you are very careful, thinking very carefully about how you can optimize the size of what is the most expensive component, the battery itself, is absolutely key to developing cost-effective solutions that can enable access to electric cooking for the poorest households. Next slide, please. So coming back to how you might identify culturally appropriate energy efficient appliances, it's important to understand what it is that people are cooking in the context that you're interested in. Establishing, first of all, what is on the menu, what are the most popular dishes, grouping them together into categories by the cooking processes that are used. For example, a chicken curry and a beef curry, although they have different ingredients, the cooking process is very similar. The same with a chicken stew or beef stew. It might have a completely different name, but ultimately they involve some frying, typically of onions, garlic at the start, and then boiling of the main ingredient, which means that an appliance that cooks one well is likely to cook the others well. And what is really important is engaging with real cooks. So understanding, talking to people, understanding what it is that they're cooking, how often they're cooking those dishes, the typical recipes that they use, and if you have the chance to carry out experimentations. You see in the picture here, we have our colleagues in Myanmar who are testing a bunch of different electric appliances to see which is the most efficient and produces the most delicious results for cooking a typical Myanmar dish, typical chicken curry. Next slide, please. So to conclude, then energy efficient electric cooking appliances have a huge potential for tackling a range of global development challenges. However, there are a range of challenges that need to be addressed that can enable this impact to be achieved. 3 areas which I think are really important to look into are enabling access to electric cooking for consumers in weak grid and off-grid regions by developing cost-effective battery-supported systems, breaking down the high upfront costs with innovative delivery models and financing mechanisms, and then identifying and optimizing culturally appropriate appliances that can cook popular local foods efficiently. So onto the final slide, I have some additional resources that you may want to explore. You can look on our website for the research program, mex.org.uk, or there's an additional website, mexplus.org, which has some additional resources on there, including a set of cookbooks, looking at cooking local foods with energy efficient devices, and a new report where a lot of the diagrams that I've been using today came from, called Cooking with Electricity, a Cost Perspective. So thank you for listening, and I welcome any questions in the chat that we can address in this session, or you're welcome to contact me by email afterwards. So without further ado, I'll pass on to Leonard to take it from here. Thank you.
Thank you, John. Very interesting and useful presentation. And I encourage all the assistants, all the participants to make your questions or comments on the chat box, and after the last presentation, we will discuss all of them. So please don't hesitate to put our speakers on the spot today and ask them questions. Leonard, the floor is yours.
Hi, thanks everyone. Thanks Ella for organizing this, Sean, and yeah, John. Also, thank you for your great presentation. Yeah, John and me, the organizations have been working together on the topic of e-cooking for quite some time, so we know each other well. And yeah, I think yeah, thanks, congratulations, great presentation. I actually don't have anything to add on this, so we might as well skip the rest. No, cool. Are you pulling up the slides from your side, or should I pull them up from my side? Ah, look, there they are. So yeah, cool. So when John is addressing the things from the scientific approach and like with a very yeah, methodical approach, we at Burn, we're obviously a company, and we're driven by the aim of actually selling those appliances. So we take a slightly different approach, although we try to be organized and methodical. Sometimes in a business environment, you need to make decisions without having all of the information available, or even having less information than you actually want to have. So that's something that also I encourage all students to do. You will never have all the information as much as we want to. It's just not possible. And therefore, sometimes you just need to make decisions on best available knowledge and move forward, because sometimes moving forward is more important than making the absolutely right decision. Because you will always learn from it. You will always be able to backtrace a little bit. As long as you have a plan B, it's yeah, it definitely gives you speed. And I think that's something in well, in industry generally, but also in the clean cooking sector is quite important. Yeah, next slide. So this is just an introductory slide showing one of our early prototypes. So why is this important? John has mentioned this already, but I think I want to emphasize this again. It is important because clean cooking is not general in practice. Contrary to what many people see and believe and see in their actually daily lives. And 500,000 of people in sub-Saharan Africa only die of respiratory diseases, and most of them are caused by unsafe cooking solutions. 500,000, that's huge, right? And this is only sub-Saharan Africa. These practices are done in all around the globe in the poorer part of the population. So yeah, make the numbers, but it is huge. So next slide. Also, most of the deforestation is caused by firewood and charcoal production. And if we're then looking at the expected population growth in Africa, namely doubling until 2040, then we see that this is important. It's hugely important now that we're solving it now, because the next generation, if we're not offering better solutions, will cut down forests. And those forests are vital to local economies, to local ecosystems, to global ecosystems, to climate change. So it's all connected. And therefore, clean cooking is one of the main important things to actually address. And it might sound a little bit like a niche thing, but if you're looking at what can actually make big impact on climate change and biodiversity, surprisingly enough, clean cooking comes up quite high. Next slide, please. So we have addressed this from early on, and we have said, well, If we're offering a cleaner cooking solution, it might not be perfect, but we can actually make a scalable, affordable solution, stoves that are burning charcoal and wood in a better way, more efficient, reducing the health impact of those cooking solutions. And we're actually now, this month, at a really nice milestone, we have sold 1 million stoves in the last, since 2013, 7 years. And obviously that impacts not only the families or the people that directly bought the stove, but the whole family. So there's a huge impact on this. Next slide, please. When we look at what's the access of clean cooking throughout Africa, and we're working in Africa, we're focusing on Africa, mainly East Africa. We're expanding a little bit, but there's so much to do here that yeah, we're not out of options yet. But if you look at the part of the population that actually has access to clean cooking, it is very small, and that's something that we really need to change. And that there's no one solution to this. We all need to address that, and that's why I really appreciate these kind of involvements of students, of universities, of organizations that are all working on this, because we as Burn only or Max or any other, we can't solve it alone. We need to do this together. Like any problem of a global scale, it is made by all of the people together, and it needs to be solved by as much as possible people that can bring this together. So now if we're looking what it is, on the left side we see what it is currently, well, numbers from 2019, and on the right side you see actually the projection, what it's expected to be in 2040. You see that the numbers are really rising in some countries extremely, but there's other countries that don't have that perspective. And also there we need to look like how can we actually make something to get those numbers up, for example, in the DRC. Obviously, this is a bigger problem than you guys need to solve now, but nonetheless, it's nice to have a look at these numbers and see where the impact can be. Next slide, please. So yeah, you have understood a little bit already about cooking, so this is not new. But obviously, many people, like even in East Africa, still cook on a 3-stone fire. It's inefficient and not healthy. We have talked about all of that. So going forward, you see a KCJ, which is an improved cooking stove using charcoal. It reduces the charcoal and the energy need, but it can still be improved. So Jikokoa, our product, our first product, and Kunyokoa, which burns wood, are even improving this further, reducing the cost for families and improving the indoor air quality. But then what comes next? Next slide, please. Well, obviously here you guys know the answer, right? This is electric cooking is big, and it comes, as John also already pointed out, in a huge variety of forms. And the key is here, figure out which one is the right one, because in different cultures, people cook in different ways. They cook different meals. It's sometimes from region to region, it's different. Here in Kenya, we have, I don't know how many different cultures that all come together. And yes, they're all Kenyans, but many of them cook very different dishes in very different ways. And so by designing the right appliance, you really need to look at who is your customer, who is the person that you're trying to solve the issue for, because any of those products here could solve a certain part of the a certain cooking need for a certain part of the population, but it might not solve everything. Next slide, please. So why is electric that big? Why is the focus not laying on LPG or other things? Well, if you're looking at growth rates of electrification projected in the next years within Africa, then you see that this is big. There is a revolution ongoing on off-grid solar, which is really helping lots of people to get basic access to electricity. But there is also a huge investment being done in all of the countries to really reach out electricity to as much as possible of the populations. And we see that within the next 20 years, we're really reaching in many countries a very high saturation of electric access. And this obviously comes with the possibility of using that electricity. And then if you're looking at the generation of electricity, nowadays it's actually more sustainable and more like economically viable to build up grids using solar, using water. So there's lots of sustainable movements ongoing in the grid as well. And that will actually help to move cooking, when we're using electric cooking, to being a much more sustainable solution than anything else. LPG, despite being clean burning, it is still a fossil fuels and emits CO2 that we also need to get rid of in some way or the other in the next years. So yeah, this is the right direction we can all agree on. And there is a good match of opportunity here. I don't really go into all of the numbers. You can get those slides later. You will look through them. There's a few more slides with numbers, but I think what matters is the prospect. Thank you. Next slide. So John already pointed out that our kind of prodigy is the pressure cooker, and this is just to take out one. This doesn't mean that any of the other solutions can't be useful, can't be addressed. I think many of the other electric cooking solutions do have lots of advantages, and you should definitely look into that and try to find the right match for the right market where you're looking at. But just this one, like similar as John already pointed out, why is this so good? Well, if you're seeing here, orange curve is the temperature in the stove. As it goes above 100 degrees, it actually cooks faster. And the blue curve, you see the current need, the current draw. So it draws current by warming up. And then there's a whole range where it doesn't draw any current. And then there's a little spike, and it bumps up the temperature again a little bit. So what we're seeing here is that because of the the regulating system in there, the thermostat, we are actually just compensating for the heat loss that occurs in the system. And when you compare that with normal cooking, like even if you're simmering on a small flame, you're always actually putting in too much energy that gets radiated, wasted to any direction in evaporating water, in radiation to the side, in convection along the pot, all of those things. But here, all of those factors are reduced, and you're really just putting in exactly the right amount of energy to finish your cooking. So obviously, as John also already said, sorry, I have to come back to that all the time, this works very, very well for long cooking foods. But if you're just making a very quick meal, like let's say tea or ugali, which is a staple food here in East Africa, then the efficiency gains are not that much, because you're still operating in the first 20-25 minutes window where you're basically heating up the food, and then that's enough. It doesn't need to boil for a long time. So yeah, looking and understanding at your customer, really understanding what are the needs is super critical. Next slide, please. Another thing that is really critical is electrical connections, the quality of that. So we see the grid expands, but it doesn't do that everywhere with the same quality. So we've seen, like, the picture is a little bit small, but you see that somebody pricked in here some cables in the wall plug, and so there's two cables coming out of the same socket. Obviously, this is not a safe practice, so don't try this at home. But it's a common practice, and there's a whole collection of pictures that we have found. So this is something that also is important to consider. What is the current draw, and what is the population that you're looking at? Do they have access to a good quality system that actually will handle the power draw of those kind of new appliances safely? Next slide. So just to summarize, you guys can make an impact, and it's important that we do this. There's families all over the world being affected by this. So if you come up with a better way of doing this, you really do change people's life. And I think this is something that we all kind of strive for and want to make. We want to leave a better world. Some little notes to do, like this. People use fuel stacking, so they will be cooking with different products, and they will be at different phases of their life buy different products. They will make cooking decisions for different reasons. Sometimes their family is larger, sometimes they need to make it quick. Sometimes they are preferring a safe way of doing it. Sometimes they're aware of the cost of cooking. So there's lots of reasoning behind which decisions are being taken. So try to really get there to understand your customer. And really, like, I cannot not say it enough. It's like you need to understand who your customer is, what they want, and that will enable you to really put up the right requirements. With those requirements, you will come to a good product, I'm pretty sure. Cool, thanks. Thanks for listening. Any questions, please let them know in the chat, and we can go through that. We don't need to go to the annex. That's just for people that that want to look in some extra numbers.
Thank you very much, Leonard. Very interesting presentation, and we will be collecting all the questions at the end. And yes, we will be sharing the slides later on. And now I would like to share a video from Biraj. Just 1 second. Just give me 1 second for the technique.
Namaste, I am Biraj Gautam. I work with People, Energy and Environment Development Association, PEDA, an NGO based in Kathmandu, Nepal. For the past 23 years, PEDA is dedicated to improving livelihood of communities, particularly the poor, by collective utilization of renewable energy resources and ensuring due care for the environment. Here at PEDA, we believe in the access to energy to be a universal right, and our vision is to address Nepal's energy system with sustainable and diverse mix of clean energy, raise awareness on climate change, and pave way for carbon neutral rural development. We have been working on various projects to improve the resilience and livelihood of underserved communities in rural Nepal. Some of the projects we are undertaking are climate change adaptation projects, research and development projects on technology such as customized research on propeller turbine, turbo turbine, electric load controller study of sustainability of microhydro, etc. We also work on rural electrification projects for energy access by using various technologies such as solar, microhydro, solar wind hybrid. Similarly, we are also working on renewable energy and agriculture nexus such as solar powered water lifting projects for irrigation, solar powered cold storage projects, etc. If you want to know more about our projects, please do visit our website www.pida.net. While working in rural Nepal, we have experienced that cooking is one of the major tasks that brings so much of burden. Today, more than 75% of communities in rural Nepal use biomass for cooking. Currently, around 92% of Nepalese have access to electricity. With the increasing number of households having connected to electricity and country moving towards improving quality of electricity, it is a high time that we work for electric cooking. Hence, Government of Nepal and number of other organizations in the country working to promote electric cooking, which is in the very early stage. But the story in the microhydro grid connected areas is little bit different. Please let me explain a bit of our experience while working in microhydro sector. There are around 300,000 households in Nepal who are enjoying the electricity provided by off-grid microhydro power. Around 3,000 microhydro power stations. They were built over the past 60 years. The communities are benefited from the electricity for lighting and some productive use of energy, but the utilization of energy is very low, less than 20% on average and as low as 5%. This means more than 80% of electricity generated by microhydro power stations are wasted. This has led to the operational unsustainability of the many microhydro stations due to insufficient income to run the system. Whereas most of the households in these areas do use biomass for their daily cooking, which has led to poor health condition because of the smoke. There are also many lives lost during the collection and transportation of biomass for cooking. To understand the opportunity of promoting e-cooking in these off-grid areas, PIDA along with University of Bristol, CAPEC and MEX are doing series of research. There are challenges to promote e-cooking in microhydro sites due to limited power generated by the microhydro stations to support the large number of households with e-cooking. The further challenges is forced by the electricity demand for e-cooking overlapping the daily peak load, the duck curve effect. High electricity demand for e-cooking is also a challenge. The currently available commercial e-cooking appliances need electricity 1 kilowatt or above. By our research, we found that the lower power, say around 500 watt, is also sufficient to cook most of the Nepalese food, though it takes a bit longer time to cook. This is a good opportunity for the researchers to work on these challenges. They might be low power consuming cooking appliances or designing the cost-effective storage system for cooking which can use the electricity which otherwise is being wasted. Or there might be many other similar areas to work that makes large-scale e-cooking possible in Nepalese microhydro communities. With this point, I would like to thank Efficiency for Access and Jacqueline for these opportunities. Thank you for listening.
And with this video, we go to the Q&A. So first of all, thank you very much for the three of you. Also Biraj, who sent that video in advance to be here with you today. So if John and Leonard, you can switch on your cameras for the Q&A. There is a, thank you. There is a question here. Just let me. Is asking about Peter Musembi is asking if you can take us through a typical design process.
Could you repeat the question? I didn't hear the end.
Sorry, yes. Peter is asking if you can take us through a typical design process, a typical, I guess in the e-cooking space.
Sure. Well, we are using a fairly standard design approach where we start with research. So we're looking at, we're defining what's the kind of space we want to look at. Then we'll define some research questions. We really look at the customers, how they're cooking, what are they cooking, and what are their main problems. And then from there on, we go to make ideas, we make sketches, we work them out into concepts, and we prototype those things. We take them back to the customers and we test it, and we try to do that as early as possible to really get the right insights, because we have to admit, we are not the users that we're designing for. So you don't actually know until you really spend time with the people that have the problem. And therefore, it's key to find the right persons and to ask the right questions. So that's what we're doing. And we try to iterate that a few times, because you don't get it right the first time. You never get it right the first time. So you do that twice, 3 times, depending on the level of the level that you want to reach, and then we're moving on to actually working it out, making a detailed design out of it, making sure that we can actually produce it, that we can, and all of those will go into the design. And yeah, depending on the complexity of the product, that can take a few months to more than a year. And then we will, during that time, always go back to the customer, make sure that our assumptions are being met. If we're changing things because out of a production requirement or a cost requirement, we will always go back to the customers and try to see, does the product that we're developing now still make sense for them? And then we will take it into the tooling phase, where we're actually tooling up for the parts that need to be done, and then we'll afterwards launch it into the real world.
Yeah, I think it's a really good answer. I think the only thing that I would add to that is that, Leonard, you mentioned it was a standard design process, and I think it is standard for human-centered design, but not necessarily for all engineering design. So I just want to emphasize that human element. It's really important, working in a development context, to always understand the people that you're designing for, and to continually go back, as you were saying, with that kind of iterative cycle, to make sure that any solution that you are proposing, does that really meet the needs and aspirations of the customers that you're working with? And then if you're going to go and trial the same solution in a different context, look for what are the similarities and what are the differences between those two contexts, and really try to make sure that you are listening to the people in that new context, to try and make sure that the solution that you've seen work in another place is really appropriate for that new context, rather than just assuming that you can copy and paste one solution from one place to another. Especially with cooking, there's so much more diversity in cooking practices than there are with many of the other end uses of energy that we see. What is cooked in one context can be completely different from what is cooked in another context, and the priorities of the cook can be completely different too. So I really think that human element, listening to people, understanding their needs and aspirations, is key here.
Yeah, absolutely agree. Yeah, thank you.
Bitsen Walia is asking, when designing the cooking appliances, what steps do you take to balance between making the appliance as efficient as possible with the amount of time that it takes for the appliance to cook?
Yeah, I mean, the two are obviously interlinked. In that the quicker that you cook, then usually the more efficient you'll be, because there's less time for the heat to escape. So ideally, from a user perspective, you want your food as quickly as possible, but also from an efficiency perspective, then you want to get that food into its finished state and ready as soon as possible. I think there are some areas where you may want to compromise between the two. For example, if you're looking at designing an off-grid solar system, you may sacrifice speed of cooking for a lower power requirement and the ability to use the power that's available when it's sunny. So in that context, something like a slow cooker may be a better fit for an off-grid system than an electric pressure cooker, which may have higher power requirements. So I really think, yeah, it's definitely a balancing act, and it's important to understand both the priorities of the customers. Do they actually want to cook faster? Does that fit with their cuisine, the types of foods that are being cooked? Some foods lend themselves to faster cooking, others don't. And then the requirements of the power system as well. Can it support fast cooking? If not, then you have to make sacrifices.
Yeah, nothing to add. This is the complete answer. Yeah, thanks.
Thank you. Leonard, you mentioned during your presentation safetiness of the appliances. So in your opinion, and maybe more based on your experience, what are the key considerations when it comes to design safe appliances?
Well, one of the things, safety is common sense, right? So you need to look at it at the first layer with common sense. At the next layer, we need to think of all options that could go wrong that you wouldn't think of like common, because they will all happen at a certain moment, just as a matter of statistics. And we just want to make sure that those also are covered. Great guidance on that there's a lot of tools out there to be able to use, like FMEAs, the fishbone matrices, failure diagrams, risk assessment tools. They're plentiful and they can be extremely laborsome. So it might not apply at every stage of the design, but you need to layer them up. So you really need to start with your common sense and then go for the best estimates of what can go all wrong, what you can imagine, and then start using more and more elaborate tools towards how further you're coming towards actually your release of the product. And then obviously there are norms, which I think a great thing of this world is like the norms that are made up to make safe appliances. So there's lots of them. The Americans have one set of ASTMs. The European Union has another one. There's international norms. Most of the countries have their own norms that are derivatives of those. So it's really important at the moment when you really are planning to put a product into the market to also look at those to make sure that the product you're designing does actually comply with all of those norms, because most of them will be built up to ensure maximum safety.
Thank you. What do you see is the role that product design can play in achieving gender equity? Who wants to take this question?
So I think, sorry, Leonard, you were going to go first. So I was going to say, I think product design, then again, looking back to Leonard's first answer, so really trying to understand your customers and the context of use. So how this particular product that you're designing is going to be used by people at all stages of the value chain. So you've got the end user, which is the most obvious way that this product can impact gender equity by making cooking easier, safer, healthier. But you've also got the other elements in there as well, as in how is this product marketed and supported. And by designing the product in such a way that it can be sold using a business model that makes it affordable to women and to men, to develop marketing strategies that can enable women to sell to other women, for example, as entrepreneurs. So by building these features into the appliance itself, for example, by developing payment mechanisms and using hardware that can enable those payment mechanisms that are integrated into the appliance itself, then you can integrate that appliance into existing systems that can empower women as entrepreneurs, not just as end users of the product. Sorry, Leonard, do you want to go?
No, I completely agree with you. I think there is definitely a big role for design to play in there, but it's intricate. It has lots of layers, and as all gender issues, there's not one clear-cut solution for it. So designers need to think of that, of the gender issue during all of the design decisions. What's the impact of that? Because the price does have an impact. The marketing material does have an impact. We see that the gender in cooking is a very clear present issue, because in many cultures men don't cook and men don't collect the firewood, and so they don't have a big problem with it. But they are often also the ones that actually do hold the money of the family. So if there is a new cooking device to be purchased, they are the ones that are making the decision. So the problem holders are not the decision makers. And obviously this is generalizing, which we should be careful with, but in many populations this is true. And so therefore we need to think of the impact of our product on all of these layers. Like, who's the end user, who's the intermediary user, who's the decision maker, on what level? And that brings you up to the place where, like, who's the decision maker in the supermarkets that decides which products are being placed where on the shelves? Yeah, definitely design has an impact there, but it's not clearly lined out. We really need to take those considerations through all of the steps of the process.
I think just building upon that, then I think it's really important to include not just the needs of women in the design of the product, but the needs of men as well, because as Leonard says, then men are often key decision makers in the household, and also not just decision makers, but also, as we know, the balance of who does the cooking in many contexts is tipped unfairly towards women. So by designing a product that is desirable to men, not only is it more likely to be purchased, but it's also more likely that men will actually use it. And by men doing more of the cooking, that's taking the responsibility off of women and freeing up their time for other activities, whatever they may choose to do with that time.
Thank you. There is a last question from Paris. Based on the downsides in terms of limitations of cooking methods, will it be viable to make an appliance that cater for all the methods, or it's an achievable option? If you can respond very briefly, because we are running out of time.
I don't think it's unachievable, but it's unlikely, let's say. I think the variety of what people are wanting to do with cooking is so huge that it's not easy to find one solution that covers all, in my opinion.
I think you could make one solution that covers every single type of cooking possible in the world, but it would be so expensive and so bulky and so inefficient that no one would ever want to use it. So it's not a viable solution. You have to make trade-offs.
Great. Thank you very much. We are out of time, and yeah, it seems that there are no more questions at this time. We value your feedback to all the participants, and we are keen to hear from your opinion in an assessment of this webinar, as this will help us to improve our further webinars. So you will have, after this webinar, a pop-up window with a very short survey, less than 1 minute. And yeah, apart from that, just to remind you that a recording of this webinar will be available on the Efficiency for Access Design Challenge website in case you want to revisit some of the examples and interesting information you've listened here today. I hope you've enjoyed and learned something today. And as this is the week of the webinars, the technology webinars, next webinar will be today at 11 GMT. It depends on where you are right now. It will be focused on power management. So hopefully you can join us later on today. Thank you all, especially John and Leonard and Biraj, and see you in the next webinar.
Thanks, Jacqueline.
Thank you.
Good luck everyone with your project.